Hi again, folks. Let me remove this banner for y'all and get right down to it. So, welcome to Global Hack Week. My name is Rosendo from MLH. I hope y'all are excited. I hope you enjoyed our previous workshop, and I hope you're excited to gear up for this next one. Hi, folks. I see that some folks are joining us from India. People are letting us know where they're from in the chat. Very excited. I appreciate it. I see some folks, very familiar folks from the previous workshop as well, and from opening ceremony. Thank you for sticking to it. I really appreciate it. So today we're going to be joined by two experts from Oracle Database. They're going to be showing us how you can use Oracle AI Vector Search in your day-to-day AI ML needs and projects. It's a really great way to sort of take your work in that space to the next level. So really very excited to be introducing Doug Hood and VJ. And without any further ado, I'll go ahead and get them on stage for us. And just by the way, make sure you keep up with the chat, drop any questions you have in there, and look for any relevant links that I'll be posting there as well. All right, folks. See you in a minute.
Good morning, everyone. Can you share your screen, please, Vijay?
Yeah. Can you see now?
Yep.
All right, thanks.
Good morning, everyone. My name is Doug Hood. With Vijay, we're going to be talking about Oracle AI Vector Search, a little bit of the theory, but more of the practice and how you can make it all work in Python using an open source framework called LangChain. Next slide, please.
Okay.
So there's a lot of theory behind AI and machine learning. What we're going to be focusing on today is where it's useful in business, i.e. where customers will actually pay you to do this sort of stuff. It turns out that technically there's really three areas or use case which are relevant. The first one's similarity search. I'm going to be talking about that. Then there's outlier detection, which is actually a variation of similarity search. And the final is retrieval augmented generation, which Vijay will be covering, which uses similarity search as a pre-processing stage before you talk to a large language model. Next slide, please.
Okay.
So one of the useful things about using vectors is that you can use vectors to do search for unstructured data. Because if you have text, images, audio, or video, how do you sort or search those things? It's just too hard to figure that out. But it turns out if you can encode or convert those different unstructured things into a bunch of numbers or vectors, it suddenly becomes easy to search and sort those things. So the magic to convert those things as unstructured data into a bunch of numbers or vectors is by using pre-trained neural network. So what they're doing is they're looking at the semantics or the meaning of the text, images, audio, or video and converting those into numbers. Next slide, please. So what we're doing is we're using the similarity property of encoding. If you take real things from the real world and map them into a bunch of numbers, things that are similar or related in the real world tend to group or cluster together once you encode them in a bunch of numbers or vectors. The number of dimensions or the size of the vectors tends to be large. There tends to be hundreds or thousands of dimensions per vector. So that's obviously too hard to visualize. So I'm using a feature visualization technology to dumb that down to 2 dimensions. The point being the property or the clustering still applies. So the point is the similarity property is such that when you have two things that are similar in the real world, where they map to in a dimensional space tends to be close together. Why is that important? Because in practice on the computer, you do the reverse. You've got some information, you encode it, and then you're looking for the closest things that have also been encoded. Things that are close in encoding also tend to be close in the real world. So that's the similarity property. So the vector embeddings are the encoding of the data onto some n-dimensional space. A vector is just a set of numbers which represents that semantic meaning. The vector embedding model is a fancy word for the pre-trained neural network, which converts the text, images, audio, or video into the numbers. And you tend to get specialized neural networks, i.e. the neural network for converting text into vectors tends to be different than the neural network that converts images into vectors. Next slide, please. So this is a build slide, you can just build it out. Okay, let's just skip that slide. So with similarity search and the similarity property, we were looking for the closest matching vectors to the query vector. So we were looking at the vector distance and trying to minimize that distance to find things that are closer. So that's similarity search, you're finding close things. Outlier detection is a variation of that. You're looking for things that are not the same as others. So you're tending to look for things vectors which are greater than a certain threshold or certain distance. So that's easy to say, but it's hard in practice to know what that distance or threshold should be. It turns out that you can use, you can use statistics theory to help you in this case. If you have a large set of numbers, large set of data points, the central limit theorem helps you in that any large population will tend to look like a normal curve. If you have a normal curve, you can easily figure out the mean and standard deviation of that data. The point is, if you have some values which are within 2 standard deviation of the mean or average value, those values which are represented on this side of the chart or this side of the chart tend to be quite small, i.e. about 4.5% of the available data. Likewise, if you have data values which are greater than 3 standard deviations, which are these extreme values on the left and right of the chart, they tend to only be about 3% of the data. So what that means in practice is you can use the standard deviation and mean to find outliers. So these are well-known values. So the point is, if you have populations of numbers, this is easy to do. But how do you do that with text, images, audio, or video? If you can encode that data into vectors and find the mean and standard deviation of those vectors, you can use these same techniques to find outliers given known thresholds which are independent of the data. So the point is, outlier detection is finding things that are not similar given some threshold. The trick is finding that threshold, and we can use standard deviation and mean to help us for that. Next slide, please. So there's lots of vector databases out there. The math is fairly easy to do. Finding the distance between vectors, whether you're using Euclidean distance or cosine similarity, Manhattan, there's lots of different distant metrics that you can use. The point is, it's easy to create and use a vector database, but there's a fundamental challenge. If the vector database is not in sync with your data, you have dirty data or data that is out of sync. When the data changes, your vectors should also change. So an easy way to solve that problem is if your vectors are stored in the same database as your data, be it relational data, JSON data, spatial data, property graph data, whatever your data is, when your data changes, if your vector can automatically be updated, that will mean your vectors will always be consistent with your data. The reverse of that is a problem. If you're using vectors for things like similarity search or outliers or retrieval augmented generation, and the vectors are stale, that means whatever result you're getting will tend to be completely irrelevant. The challenge is you may not even know that. So if you have a vector data store which is separate from your business database, that's a challenge. By storing your vectors in the same database as your data, you can avoid that problem. We can do that with Oracle Database 23 AI because we can store all of those types natively in the database. Next slide, please. Because you can have a large number of vectors, you need to be able to search those vectors very efficiently, i.e. very fast. You want to be able to get answers in milliseconds, not seconds, minutes, or hours. So the trick to do that is you use vector indexes. So all vector databases use some form of vector index. Two of the most popular vector indexes are in-memory vector index, HNSW, for hierarchical navigable small worlds, which is a very fast in-memory data structure. Obviously, you're limited by the amount of memory you have, so you're going to tend to do that in the order of millions of vectors. If you have billions or larger number of vectors, you need to be using some disk-based index. IVF flat is an example of that. Next slide, please. So this is a build slide. This is the HNSW vector. How it works doesn't particularly matter. The point being, it, like a B plus tree index, tends to give you order, log n, performance, or access. So the point being, you can get very fast access no matter how many different vectors you've got. Next slide, please. This is a build slide, so just keep going. So as we saw with the similarity property, your encoded or vectorized values tend to be clumped or clustered together. So we use that property with the IVF flat vector index. So by computing what those clusters are, you can then look at a subset of the clusters to get faster access to your data. Next slide, please. What VJ is going to be showing for an implementation of retrieval augmented generation, which is a fancy way of saying making large language models better and smarter, is, so he's going to be doing all of that in Python. With the Oracle database, under the covers, we do it all in SQL. For VJ stuff, you don't need to know what the SQL is. I'm just giving you a quick hint or suggestion of what it can look like. It can be as simple as selecting a few columns from a table and using SQL functions like vector distance to figure out how close the values are. So I'm not going to go into the syntax, but it can be as simple as that. Can you go to the next slide, please?
Mm-hmm.
You can, because it's using SQL, you can also add an arbitrary number of where clause to filter that query. So not only are you doing vector distance, but you can add other attributes, in this case, where the city is San Francisco. Next slide, please. Because it's SQL, we can also do vector distance over arbitrarily complex joins. So in this case, we're not just doing a vector search from a single table, we're joining tables, we've got business conditions like the city and the spending limit and vector distance. So the point is, doing vector search operations in an Oracle database, you can leverage all of the capabilities of the SQL language in the Oracle database. So whether you're adding where clauses, doing joins, doing analytic queries, doing spatial queries, doing JSON queries, doing property graph queries, you can do any or all of that. The point being, your data model and your business use case will tend to determine how complicated the queries are. So the point is, there's a lot of sophistication there. It's going to automatically use the vector indexes. And it's going to take advantage of the cost-based optimizer. So the point is, if you know SQL, there's a lot of power and flexibility built in there. If you don't know SQL, it doesn't matter, because what VJ is about to cover is using a Python API, which has no visible SQL, because all of that's under the covers. Next slide, please.
Okay.
And that's it from me. So I'm now going to hand over to VJ, who's going to talk about using LangChain for retrieval augmented generation.
All right. Thank you, Doug. And uh, the third, it was a wonderful overview of things you can do. So, with the similarity search and deep standard deviation, the third comes the RAG. So, in order to tell the story of what RAG is, I have a demo of what we can do with these LLMs and why we need RAG. So essentially, most of you have already tried out or tested with Chat GPT, where we ask a question and it returns a very nice answer. We could ask some coding questions, you will get answers. So it is a very powerful tool already, and some of its uh, if you have what to say college projects, I know people who have done many of these using these LLMs out there. So it's very powerful, generate very good responses, multilingual, so you can even translate uh, text or data from one language to another. And the common one, most common, is Chat GPT. Oracle has generative AI, and so on. So you have a lot of these models that can do it. The cons in this is uh, well, you can't completely trust the data you receive, because it is as good as the model data it has been traced on. So often, or not often, once in a way, you can see wrong or incorrect answers or hallucinations, the model may not be trained on this particular type of data at all, so it may not know the answer. And the other is public LLMs are not secure, so you can't ask a question on private data. So if you are a corporate and your business runs on secure private data, you can't really send those data across to a public LLM and ask questions. So that's one of the security threat, and can it can be costly to uh, what to say train a model. So those are some of the cons of it. So I'll do a very quick demo of a Chat GPT for people who are new to it, and then tell where we can make it better using the RAG technology. So here is uh, my version of the Chat GPT. So I will ask a simple question, like write an ad on wool sweaters for uh, Zara sweaters. So let's just run that and see the answer. So uh, it is excellent to give generic answers. Uh, Let me try again. Okay, so uh, it really is writing some in a blog format why stay warm and what to say perfect for any occasion. You can also say add information like there is a sale on buy one get one 50% off, include that in the ad, and it can include that. And it is very powerful to do these. And not only that, you can get into coding. So if I want to say write a Java code and a Python code to connect to Oracle database or Oracle autonomous database with the wallet, so very specific question. So if we ask that here, not bad. Based on the public documentations and manuals, it is actually giving us the code of how to connect to an Oracle database using the JDBC driver. When case of Python, use the cx underscore Oracle driver to connect, and the more information about the wallet. So you can ask it intelligent questions, both for coding as well as your regular stuff. I have another question in terms of coding is write Python code for a game of Pong. And I have run this earlier. It works. So you can do changes to it once you have. So most of you, or most of the this was one of the first video games of our time. So you can play the Pong game using Python code, which an LLM created for us. So here, essentially, what we are doing is we are asking a question in natural language. The LLM understands our question and is able to provide an answer. But now, if we go to things like uh, private data, uh, it won't. It can do a good guess, but it does not really have the data, right? So this is where uh, the issue comes. Is if I ask a personal question like what is the approval steps for Oracle hybrid work. So based on the model training data, and which is based on public information, it can give some information of what is the standard procedure. It might be pretty good, but as I mentioned, based on some public blogs and some Oracle blogs, it can give an answer. But we have, let us say, a document which has that information, but it is a restricted document. I don't feel comfortable reading the data from that content, putting it in part of a question and send it to a public, what to say, LLM to get an answer. So this is where the security concern is one of the key things for corporates. Is you can't send restricted or private data to a public LLM. So that is where we can work on RAG. So RAG is, you can send or to say, store your public private data in a vector store, ask your question, which will pick up the relevant information from your private data, get those questions and the equivalent text for it, which has the potential answer, which Doug mentioned of clustering and searches. You will get the relevant text. Those text you can send it to a private LLM, or with Oracle GenAI, you have what to say, within your own network, you can have a GenAI service which will run the LLM for you on the network. If you are still not comfortable sending it to anything outside your data center, you can build those LLMs within your data center. So here I will upload a restricted document, uh, and then ask the same question. So and now, essentially, when I'm uploading this file is read from our LangChain application. It is broken into pages, and each of these pages has a vector mapping. The question also is converted into a vector. Vector is now, we are doing similarity search within the database for what are the text chunks which have relevant answer. It will pick up top 5 or 10, however you code it. That is now sent to a generative AI, and that will process the data and retrieve the data. So it took me 1.2 seconds to load The search is extremely fast because it is vector searches. The data that is got out of it is, well, there is a one-to-one mapping between the, let us say, PDF pages to a vector. So those pages that come out of the search are sent to an LLM. LLM then, along with the question, understands uh, and gives answers. So this is something what a public LLM cannot do. And where RAG comes into picture is you now provide some additional information so that your LLM can answer with more information. So again, the use cases are chatbots for a private sector, and uh, more like writing advertisements based on additional data, other than just the LLM component. You can pass additional private data and get those things. Another example is, there are some CD rates for high credit score people. So you can pick up the data for what is the CD rate for a particular person, customize your email, and then send it across. So those things you can do with these private LLMs, and this is an example of a complete RAG implementation. So with this, I will go back to the slides and show the steps that have happened in between. So again, the LLMs are good. The only way you can improve LLMs are giving better prompts. So in case the answer you got is not up to what you wanted, you can re ask the question with better, more information. So there is an entire class for better prompt engineering, where you try to give better prompts or questions which the LLM can answer. The other option is to fine tune the model, retrain the model with more data. And those are very expensive and time consuming. And so the best option really is RAG, where you send additional information, and then based on that, you get enhanced answer or augmented answer, better answers, more accurate answers based on context. So another use case is, I have my annual checkup, which is and I don't want it to send to a public domain, but I'm okay to send it to an LLM which is on my domain, and find out whether I have what are my sugar levels, cholesterol levels, whether it is good or bad. Those questions you can ask as through a chat bot sort of a option. So that is RAG. So RAG improves generative AI by augmenting prompt with private data content, and augmenting simply means enhanced answers. So this helps produce better and more accurate answers to user questions. Okay, so how do we do that? I briefly explained, but a user natural language question is encoded into a vector and sent to a vector search component. Your documents or private data which you want to search is already in the vector store, and you are doing a search on that. There is a one-to-one mapping between the vector and the corresponding chunk. So the chunk can be an audio, text, or image. So once the search is done, you can say you are picking the top 5, top 10, top 50 of those documents or audios or images that are valid. You send that along with the user question to LLMs. The LLMs like Oracle Gen AI will then process the question along with the additional text you are passing, and then the user gets the answer. So more accurate. Your data is still in the vector store, which is completely private, and you are not sending more data or the entire document, just chunks that are relevant. And you can keep the Gen AI within your domain as well for additional security. So this is RAG in a nutshell. Private content, secure, relevant data, and up-to-date content, because uh, it's mostly you can run this out of your production environment, no matter what the type of data you are storing. If you are storing up to date data, you can vectorize it as and when data comes in. So your search for documents for similarity search will be running through the entire list of up to date data. Okay. So that was the demo. Uh, all this happens with the backend. Backend can be LangChain, Lambda Index, Java programming, even PL SQL. There are any language you choose, you can put to do this RAG. At the same time, your application can be front end, can be anything. It could be Java or any GUI. You can interface where you can pass in your question and then call these APIs in the front end. And LLMs are good to do what they are good doing. So uh, in our demo I showed, I first uploaded the file. That file, you are extracting the pages. Again, all these are part of LangChain libraries in Python. I coded it in Python. So I'm extracting the pages. And even those pages may be too big. So what I'm doing is I'm chunking them into smaller pieces of each chunk being 1500 characters in my case, and then I'm embedding it. So there is a one-to-one mapping between my text chunk and the vector I'm creating. So embedding is the name for vectorizing your text chunks and storing it in vector store. Vector store can be anything. With Oracle, you just have to change very minimal code to point to a Oracle database with this username, password, and connect string. The LangChain Python code will do all the things underneath it. And when you ask a question, like I did in the prompt, the question also is embedded in the same model as the data which I'm loading. So if this is using a certain model, the question also has to be uh, vectorized in the same model, and then the search happens. Once the search happens, the similarity search is in milliseconds to microseconds. uh, even even when you have thousands of data. So that is where performance scaling of these vector store matter. For a small test case, is any shareware or freeware will do. But when it goes to scales to millions to billions, and you still want sub-second response time, similarity search are best in Oracle. And then once you do the search in milliseconds in a vector store, you send the resulting text chunks. Let us say, in this case, blue and red are the text that can answer the question. Then those two blue and red text are then sent to the LLM. The LLM then responds with an answer which is more relevant, because you are passing uh, relevant data from your database or vector store to the LLM. So that is, in a nutshell, the complete life cycle of a RAG application. About all implementation of uh, the AI in recent project, about 90 plus percentage are all in the realms of doing RAG with LLM using any of these languages. And again, I mentioned text, but it's not limited to text. Anything can be vectorized, and they are just numbers. So text or images. So here there are images of cats, dogs. Uh, all these can be vectorized. And for deployment, you can run these AI services where you run it in your own domain, or you can just use bare metals servers and install your own LLMs to get answers in your private secure one. And this can be done both in online or on premise in a secure way. Again, ways to develop RAB applications are plenty. Python, Java, Node.js, .NET, even within Oracle. Everything I mentioned is, if you are more familiar with SQL or you are a DBA, uh, everything a LangChain code can do, our PL/SQL can do, or at least for implementing what I demonstrated. I have a lab on both LangChain and PL/SQL, so we can do that in LangChain, Llama Index, and other stuff. So exactly, I've been talking about LangChain. So what is it? LangChain is an open source framework uh, which has emerged as a one of the popular ones to develop these RAG applications. It can do pipelining from uh, traversing through multiple chains of different models. It has yeah, it has a framework where many of the vendors, including Oracle, can provide implementation libraries, and so with very minimal change of code for your RAG application, you can change the components of who is providing what. So from a, say, free vector store database, you can simply swap out the connection to an Oracle database and you have a vector store in an Oracle database. So it's that easy. Let me just show you the Oracle component here. So if you go to the web page, the Oracle component, you can download. The basic prerequisite is you need a driver to connect, and the specific Oracle code to connect is just username, password, and connect string. We also saw in my chat GPT question how to connect. It is the same code. You then download uh, uh, one additional library, which is the Oracle implementation of vector store. Rest of these are all common implementation from LangChain, and then you can do things like in addition to this, you have more things like text splitter, PDF reader. So I will show more of the code as well. And then if in case you want, Doug mentioned about two additional indexes. By default, LangChain implements indexes, but if you want some finer tuning, you can do vector store create index as a parameter. But essentially, that's about it. It's a framework, and Oracle is one of the data store for implementing RAG. Okay. So just to show more components of it. So once you do the connection, I'm using PDF reader to read, extract the pages, and I'm using character splitter. Again, all these are free framework from LangChain. I'm splitting the text and I'm sizing it to 1500 is the chunk size, and an overlap of 200, which means that the last 200 characters of page 1 is the first 200 characters of page 2. So these are minor tuning things in your RAG application. So assuming your question can span through two continuous text chunks, so there is a potential that both can get selected, so you'll get more contiguity of your answer. So these are just tuning parameters. And then uh, I mentioned all these are nothing but text chunks are arrays of text. You wrap it around to create it in a format LangChain requires, and all that requires is a doc with an ID, some metadata, and the text component of it. You pass it as you initialize LangChain and then pass it or create an array of these documents in a format LangChain would understand. You initialize a model, and then that's it. You create a vector store. In vector store, you pass the LangChain document, uh, the model you want, and this is the connection initially when we connected, and the table name. It will create a table for you, but just the vector store name is what you can think of, and the search similarity search criteria. So here I have chosen cosine, but there are others like dot and equidian you can use as well for searching your data. So these are again additional tuning parameters. And then the user question. So things like, let us assume I have put in the Oracle manual, the latest manual for the next release in my RAG application or AI application. I have uploaded, so I can ask it list 10 new features of 23 AI, and what it does is the question is passed and you get the result. So this is where you pass uh, question the question into the vector store. Vector store will do the similarity search, pick up the text chunks which are more relevant, pass it to an LLM. LLM will take the additional text and return a response which is more user friendly and natural language, so you can read it properly. So that's how you can send the uh, store. So here is a way you initialize the LLM, and once you initialize the LLM, you pass the user question and the text, and you get a response. Uh, and this same thing what we can do with these LangChain, you can do it in PL/SQL as well. These are the equivalent options. So these are options, and there is a live lab for it. So the way I go, if you are interested, it hardly takes any time to implement it, but fairly easy. The way I go to these live lab session is I just search for uh, live labs Oracle, and I get to the very first page. I click on that and I just search for the word RAG. And yeah, so your live labs like AI vector search and the PL/SQL one, if you're interested, it takes very less time to implement it, but extremely useful to get an understanding. So now is where people will start paying for what to say, these solutions you would be building is Oracle has already come out with additional functionality like multi-node high availability clusters which can run things in parallel across a cluster. Analytics, machine learning is built in, and it can run things extremely fast with parallel execution and partitioning, and security as always a part of any core database. So the differentiator is it can scale out extremely fast in searching, very simple implementation, and you can do combine any sort of sophistication along with this search. So that's the key differentiator. I will stop uh, my presentation, and we can go for the question and answers now. Yeah.
I'd just like to say there's been some great questions on the chat. Obviously, based on the questions, you guys know what you're talking about. Hopefully, we've answered those questions. We're happy to answer more questions in chat or live if that's possible. So I just saw a question about the link to the hands-on labs. That's going to be provided. I'm not sure if it's necessarily in VJ's presentation, but that particular live lab and a bunch of others will be challenges which are part of the hackathon for this week. I think that link has just been put up. Yes. So those challenges, which includes VJ's live lab, is highlighted on the screen now. And we will make the presentation available.
Yeah, and Doug, do you want to add from your wisdom anything I might have left out, or on the aspect of RAG? While we are at it, we have a few minutes.
No, I think you covered it all well. I'll just quickly summarize it. You can talk to a large language model directly, and that works. It's easy. The problem is there's some challenges with large language models. Sometimes they don't know the answer, and if you're lucky, they'll say, I don't know. If you're unlucky, they'll make up an answer or hallucinate, and you don't necessarily know that answer. Any large language model is only trained on publicly available information. So the whole point of RAG, or retrieval augmented generation, is to take the benefits of a large language model and combine those with similarity search so that you can get the best of both. So when you have a business, whether they've got data in their databases or files in their file system, are they PDF files? Are they Word documents? Are they emails? Are they spreadsheets? Are they PowerPoint? It's whatever the data is. The point is you can get private information from your company. You can easily upload, chunk, and vectorize that data so that you can do similarity search on it. Yeah. Given the similarity search, you can feed the output of that similarity search into the large language model. So RAG is really about doing similarity search on your private data and then passing that as a prompt to your large language model. So that's an architecture. You can do that by hand in whatever your favorite language is. The benefit of using LangChain is it's all in Python, so the code's pretty easy. It's a very popular open source framework. So everything's just function calls. So you need to know what to do, not so much how, because it does it for you. So RAG is an architecture, LangChain is an implementation. The point being LangChain will do things like take your data files, upload them, chop them up into smaller chunks so that you can easily vectorize it, vectorize that data so that when you ask a question, it's implicitly doing that similarity search first under the covers, and the output is passed to the LLM, and then that answer is passed back to you. So that is retrieval augmented generation, is taking the benefits of a large language model and addressing the issues. By using facts from your company, you're much less likely to get hallucinations because you tend to ask questions about your company, you're using information from your company, so you tend to be getting answers based on facts versus whatever random information was trained based on scraped data on the internet. So you tend to get training based on facts, based on private data. So it tends to be far more useful than talking to a generic LLM trained only on publicly available information, such as ChatGPT. So it's the benefits of large language models without the downsides. So that's just my summarization. I thought VJ covered it quite well. Lots of questions in chat. So I'm just going to hand it back to you, VJ. I'm just going to quickly look at chat again.
Okay.
Yeah. So just looking at questions, does database 23 AI automatically vectorize data entries? Kind of, it depends. So you can do that in SQL. You can do it in LangChain. Like, the point is, there's many ways of doing it. What's your favorite language? Do you want to do it in Python? Do you want to do it in JavaScript? Do you want to do it in Java? Do you want to do it in Go? Do you want to do it in Rust? The answer to all of those is yes, of course you can do that. So do you want to do it in SQL, or do you want to do it in LangChain? Do you want to do it in PL SQL? Do you want to do it in Llama Index? There's many, excuse me, there's many different ways of doing it. Pick your favorite language, and there's a corresponding answer. So what mechanisms are there to incorporate feedback and continuously define the RAG system? That's a really good question, and the answer is complicated and long. There's many different aspects to that. That is a whole presentation in itself. So I'm going to let that one slide. A question you might be better answer, Vijay. How does LangChain assist in crafting effective prompts for large language model based on the retrieved data? Can you take a stab at that, Vijay?
Yeah. How does LangChain assist effective prompts for our language model based on the retrieved data? So it is more a framework. You can do things like chatbot, where you can store additional information, part of your LLM, keep the context of your chat, and then in addition to that, pass more data from the search criteria. So it just depends on your application of how you can make RAG more relevant. So LangChain by itself does not do that. Another challenge is, you had mentioned about
If I could just add to that, Vijay. So everything Vijay is saying is correct. Another aspect of it is there are many different LLMs, and they all have slightly different prompting syntaxes. Because LangChain is a meta framework, it knows about different LLMs, and given a question, it's basically putting it in the correct prompting format for you. And as one of you said, it basically has a prompt template library. So it's kind of like Ruby's on Rails in that you're taking best practice and applying it. You can obviously override that. So, I mean, it's a good question. The answer can be very long. I'm just giving you the simple question. I just want to answer another question. How does LangChain handle dynamic or real-time updates to the retrieval phase of the RAG system? So this is important. If you have a static system which doesn't change based on changing data, I would argue you have a useless system. You've got data. Is that data in your database? Is it your files in your file systems? In the real world, data in database changes all the time. New files are created, files are modified. If your RAG system cannot handle those changes in real time, it is not a useful RAG system. So what we're fundamentally doing is taking data from the database and or data from files, documents from wherever. We're putting them in the database and we're querying them. We can, because it's a database, when those things are updated, we will update the vector, we will update the vector index, so that you're going to get real time, as soon as the data changes, as soon as you make a query, it can reflect those new changes. If you don't do that, you've got stale data, you've got a useless system. I'm seeing another question here. When we're using RAG, getting private. Okay.
I covered that in the slide as well. But go ahead.
Yeah. So there's a really important question here. When we're using RAG, getting private company data and then sending it to LLMs like OpenAI, how do we protect the data in this case? This is really, really important. If you take private company information and send it to a public LLM like OpenAI, you are giving away that data. That is a data leak. That is a major security issue. So most companies aren't allowed to talk to public large language models for that exact reason. So the way you get around that is, instead of having a public large language model, you have a private large language model that is within your control. So whether that's within your data center or within your cloud tenancy, the point is your business data never goes outside your realm of control. So whether, so you control the large language model. Now, a year ago, that was hard because, who knows how to manage a large language model? Nowadays, that's trivial. You can use technologies like OLAMA or Llama file, which are generic LLM runtime containers, which you can then plug in popular open source LLMs like, Llama 3 or Gemma or Mistral or whatever the coolest LLM of the day is. The point being, provisioning, managing, updating, the whole lifecycle management of large language models is now easy and efficient. You can use CPUs and or GPUs. So the point is, don't give your private data to a public large language model because you're giving away your data. Instead, send it to your private large language model, which runs on your laptop, in your data center, or within your cloud tenancy. So the point is, that's a major security issue. You avoid it by, don't give data to public LLMs, only use private LLMs. Great question. You were saying, Vijay?
Yeah, my slides sort of covered it. Like Oracle can offer you Oracle Gen AI, which is a cloud service in your private domain, or like you mentioned, Llama 3 is the latest one. I think the 4 has come out, which you can run on your private data center as well. Yeah, but
Yeah.
yeah, privacy is the reason why people will not go to open sources. But open source is pretty good for maybe day-to-day work, but when it comes to corporate data, it's not possible.
So just looking at the time, I think we've got time for 3 more questions, which I'm seeing. There was a
Yeah.
follow-up question. You don't need to build a large language model to use a private large language model.
Yeah.
I use lots of private large language models. I don't know how to create a large language model. I don't need to know. You download the runtime, be it OLAMA or Llama file. If you can't do that in under a minute, you're doing something wrong. It's literally that easy. Once you download it, you then just say load Llama 3 or load Mistral or load Gemma, which will load the metadata needed for those large language models. And those very popular, high quality open source large language models are up and running. So one of the questions is, how can you use OpenAI locally? To my knowledge, you can't. OpenAI has a business model, you pay them money. Why would they want to give away something that they charge for? So the point is, the equivalent open source large language models have very high quality, they're very easy to configure, use, and update. So you don't need to know how to build a large language model. You need to know how to cut and paste a command which downloads a file and configures stuff for you. It can run on your laptop, it can run on a Linux machine, it can run on a Mac, it can run on Windows. They've made life really simple. Excellent questions. I think we've run out of time, so I'm going to hand that back to
Rosendo. Thank you, Doug. Thank you, VJ. Really appreciate the time you took here today. For the folks that are joining us from home, obviously, if you have any additional questions that didn't get covered during today's workshop, unfortunately, the limited time has basically disallowed us from covering every single one. But definitely go to our Discord server, drop your questions in the Ask Oracle channel. We have tons of people that are there, including like Doug and VJ, who are going to be able to come in and really like handle a lot of your questions specific to Oracle database 23 AI, vector search, any of the other things that you were asking about today, and any of the topics that were covered today. Once again, Thank you so much, Doug, VJ. Such a pleasure to have both of you, and I'm sure the folks at home are feeling very similar. As far as what's coming up next, make sure you stick around because Alberto is going to be coming up and talking a little bit about machine learning as well. All right, folks. Well, it's been real. I appreciate everyone, and once again, thanks to the folks at Oracle.
Thank you and goodbye.